is graphing and why I don't like graphing systems of equation. Graphing correctly means that you have to have a perfect xy plane with perfect distances. It also means you have to have perfect equations that end at the right place. Because this won't work if your answer is like 3.2 and 4.45, because there's no way to find that on the graph. So this is probably our least effective way. It's really quick if it's already drawn out for you. So if I give you these two systems and I draw this graph and I ask you what is the solution, you're just going to pick that circle right there. I'll pick a different color because there's already red up there. Let's use purple. I would just say my solution's right there, which would be the point. -3, 1. And in order to be a solution to this system, that means when I plug -3 and 1 into either one of those equations, it should work out. So I won't do this very often. Most of the time I'm just going to do it in my head along with you. But if I was taking a test, I would very quickly, either writing it out or in my head, I would check to make sure that this is true. So I'm going to plug -3 in for x and 1 in for 2 and make sure it works out. So we'd have -3 plus 2 times 1 is going to equal -1. Yep, that works out. And my other check would be plugging a -3 in for that x, so I'd have 2 times -3 plus 3 times 1. That's going to equal a -6 plus 3, which equals a -3. It was supposed to equal -3. We're good. That is the solution to both of them. All right, more often than not, I'd probably give you one that looks like this, where you actually have to show me you can graph. All right, this one is, do you understand that where they cross is a point? This one tells me whether you can graph or not. There's two methods to graph this. You can find your x and y intercepts by either plugging a 0 in for x or a 0 in for y. I'm just going to go ahead and I'm going to put it into slope-intercept form. So to put it in slope-intercept form, I need to have y on one side. So I'd move the x to the other side. So that'd be y equals -2x minus 8. Then I'd multiply both sides by a -1 to get me y equals 2x plus 8. And it's called slope-intercept form because that 2 is my slope, and that 8 is my y-intercept. Our y-intercept. All right, since 8 is my y-intercept, all I'm going to do is along the y-intercept, I'm going to find 8, and I'm going to put a point right there. Okay, my slope is 2 and slope is rise over run, but that's just one number. What's actually my run if my slope is 2? I have the rise is 2. What's the run?
1.
1. So that tells me up 2 to the right 1. Up 2 to the right 1. The problem is if I go up 2, so if I go up 2, right 1, I am way off my graph. So if I'm off my graph, I'm just going to reverse the order. Rather than going up 1, right, or up 2, right 1, I'm going to go down 2, left 1. So down 2, left 1. So it's almost like -2, -1. So I go down 2, left 1, down 2, left 1, and that should be enough. That'll be enough to make my line. Okay, then I'm going to do the other one. I'm going to put that into slope-intercept form. Slope-intercept form needs y on one side, so we'll have 2y. That's going to equal -x plus 6. Divide both sides by 2, and we're going to have y equals a -1/2 x plus 3. I'll pick a different color. We'll pick red. All right, so once again, we're going to go to our y-axis and plot a point at 3, because my y-intercept is 3. Now my slope is -1, 2. So that means I'm going to go down 1 to the right 2. So down 1 to the right 2. Think of it as -1, 2. Well, that's not going to get me to the line. I could either Draw my line here. Oh, go the opposite direction. Up 1, left 2. So up 1 would be plus 1, and that would be my minus 2. And that would be my next point. Well, that's where they overlap. So without even plotting a line, I already know what my answer is going to be. But I'm going to go ahead and draw my line. There is my line. And this point right here where they intersect is going to be our solution. That is negative 2, 4. I think it's 4. I can't read it. I wrote all the way over it. So that is negative 2, 4. So there's two ways to do the solution. You can just put negative 2, 4. I'm okay with that. I'm also okay if you say, well, my x is going to equal negative 2, my y is going to equal 4. I don't care which way you put it. It's the same answer. All right? Now what I do in my head is I would check this. I mean, it's too complicated. Obviously, I'd write it down. But we have x equals negative 2, y equals 4. 2 times a negative 2 is negative 4. Minus 4, that gives me negative 8. Negative 2 plus 2 times 4, well, this is 8, so it's negative 2 plus 8. Yep, that equals 6. I have the right answer. So I may not write this down every single time, but you should be doing this check every single time. All right. My favorite, except for matrices, is elimination. This is my favorite way to solve sans having matrices. All right, elimination. The key to elimination is I need to have a zero pair. It's reliant on the fact that we get rid of one variable. So what I mean by a zero pair is I literally mean a pair that when you put together equal 0. So that's my zero pair. When I add them together, they equal 0. So once I have a zero pair in both sets, we just add them together. So I got 3x plus 2x equals 5x. Negative y plus y, that's my zero pair, so it should be 0. And we have 10, so 5x equals 10, so x just equals 2. I do have to figure out what my y value is, and that's just plugging in a number. And you can pick either one of these. I usually pick the easier one. Neither one of these is super easy compared to the other, so I'm just going to randomly pick the top one. So I'm just going to take the top one. So my top one is 3x minus y equals 9. I'm going to take this 2 and replace it in for that x. So that's going to give me 3 times 2 minus y equals a 9er. 3 times 2 is 6. So we're going to have y equals 9 minus 6, which is 3. So my y equals a negative 3. Just going to double check. 3 times 2 is 6. 6 minus a negative 3, well, that's plus 3. So 6 plus 3, yep, that's 9. I have 2 times 2, which is 4, plus a negative 3. Yep, got 1. All right, our next one does not have a zero pair. So I can't tell you exactly how you're going to create a zero pair because it's going to be different depending on what your two systems are. But in this one, I'm going to have to multiply the top and bottom by different numbers. And in fact, to be a zero pair, I need to have a positive and a negative. Both these are positives. Both of these are negatives. So one of them is going to have to multiply by a negative number. The other one I have to multiply by a positive number. So what I'm going to do is I'm going to multiply the top one by a negative 3. If I multiply the top one by a negative 3, what do I need to multiply the bottom one by to create a zero pair? Yeah, 2. Because negative 3 times 2 is going to be a negative 6, so I need 2 times 3 to be a positive 6. So we're going to multiply this by 2. And my new equations are going to be negative 6x plus 9y equals, this is where a lot of people make mistakes. I'll get a lot of tests that have negative 2 there. They'll be fine distributing it here, but they'll forget to distribute it all the way over here. We distribute this negative 3 all the way to everything. So rather than negative 2, It is actually going to be a positive 6. All right, we distribute that 2. We have 6x minus 4y equals 24. Well, here's my 0 pair. As soon as I have a 0 pair, I just add the 2 together. And I have negative 6x plus 6x. Well, that just cancels out. I got 9y minus 4y is 5y equals 30. Not 6, but 30. So we have y equals 6. Now we just pick either one of those to plug y equals 6 in. Once again, neither one's easier than the other. So I'll just take the second one this time, I guess. 3x minus 2y equals 12. Take the fact that y actually equals 6, and we'll have 3x minus 2 times 6 equals 12. So we have 3x minus 12 equals 12. Add 12 to both sides. We got 3x equals 24. So then we're just going to come up with x equals 8. So 2 times 8 is going to be 16. 16 minus 3 times 6 is going to be 18. So we'll have 16 minus 18, negative 2. Yep, they're both going to work if you just plug them in your head. All right, that's elimination. The very last method we're going to learn is substitution. I like elimination better than substitution. Substitution, we need to solve for one of the variables. We need to solve for one of the variables, and we need to plug it in the other equation. Once again, you're going to have to pick out a variable on your own you're going to solve for. I typically try to pick the easiest one possible, so I look for the one that's the loneliest. And right now that y looks pretty lonely because it only has a negative 1 attached to it. So I'm going to solve for that y. I'm going to solve for that y. And so I'm going to have negative y equals negative 3x plus 6. Continuing on, I'm going to have y equals 3x minus 6. So now that I have y equals 3x plus 6, I'm going to plug this in the other one. You can't plug it back into the same one that you just worked with, so it has to go into the other one. That's going to give me 6x plus 5 times that 3x minus 6. That's going to equal negative 23. Continue on quickly. I got 6x plus 15x minus 30. It's going to equal negative 23. 6x plus 15x is 21x. I add 30 to both sides. That's going to give me equals 7. X is going to equal 7 divided by 21, which equals 1/3. Now we have to pick one of those equations to plug x equals 1/3. And once again, I'm going to decide which one looks easiest. Well, for me, that first one looks easier than the second one because the first one has just 3x minus y. And in fact, what you can do is you can just take the simplest one, that guy right there, and just say y equals 3x minus 6. Let me put this in red, and take that 1/3 and plug it in for that x. But no matter what x you replace it for, it's going to come up to the same answer. So if I plug into the first equation, that second equation, or that modified equation, doesn't matter. This is just the simplest because it's already solved for y. So we'll have y equals 3 times 1/3 minus 6. 3 times 1/3 is 1. 1 minus 6 is y equals a negative 5. And if we plug those in, they will both work. Like I said, you should at least mentally check to make sure they work. Because you don't want to get, especially if I put this on a test, this should be an easy point. You've done this in Algebra 1, you did this in Algebra 2, we did a quick rehash of it. So there's no reason for you to get this wrong, except for if you just make a stupid mistake and you don't check it. All right, some terminology stuff. Consistent, we already talked about that. Consistent means there's at least one solution. At least one solution. Then two offshoots for consistent are independent and dependent. So independent and dependent are both consistent. Independent has exactly one solution. And what that looks like, if you graph it, is those intersecting lines like we had on the first two problems. That is one solution, so that is going to be independent. Dependent is infinitely many solutions. On a graph, that's going to look like overlapping lines. So they'll just be on top of each other. That's infinite solutions. Let's go to elimination or substitution. If you come up with x equals 3 and y equals 4, obviously this is just an example. Every time doesn't have to be 4 and 3. It's any one of ours above there. If you have x equals some number and y equals some number, it's one solution, so it's independent. If you use substitution or elimination and your variables drop out, all right, at some point, all of a sudden you realize you don't have any x's or y's left. They cancel each other out. You're going to end up with a statement that's either true or false. So you might have something that says 3 equals 3, 0 equals 0, 9 equals 9. If that statement is true, you have infinitely many statements. However, or solutions, not statements, solutions. If, however, this is false, so your variables drop out and it turns out it's false, something like 5 equals 9. If it's false, it means there are no solutions, which means it's inconsistent. This will also appear as parallel lines on a graph. They will never have the same answer. That's what parallel is. They'll never intersect. They can never have the same answer. So once again, consistent, at least one solution. You have one solution if you have x equals and y equals some number. If your variables drop out and everything is true, 3 equals 3, that true statement tells me it's dependent. If it's false, it's going to be inconsistent. All right, we just have one more problem. It's a really easy word problem, so don't freak out about it. Don't freak out. Who's freaking out? Okay, that's what I thought. What? All right, we got two people on, we got a person on a stakeout. So while on stakeout, protecting Earth from the scum of the universe, awesome. Agent Mulder observed 5 men in black enter a coffee shop and get 3 donuts and 5 coffees for $3.30. Next, 3 aliens in disguise entered the shop and got 4 donuts and 3 coffees for $2.75. How much does the coffee cost and how much does a donut cost? So all we're going to do is we're going to pick variables to stand for stuff. So I'm going to say donuts. I know people like X's and Y's, but I like, if I have donuts, I'm just going to call them D. And my coffee, you're going to be shocked, I'm going to call it C. Then when I get to the end and I have X's and Y's, I don't know which is which, but if I have D's and C's, I know exactly what I solve for. All right, so the first equation we have is 3 donuts plus 5 coffees equals $3.30. My second equation is 4 donuts plus 3 coffees is going to equal $2.75. And I want to do it the same way across all 3 classes. Or maybe I won't. Yeah, I guess we won't. All right. We are just going to say, well, I need to create a 0 pair. I need to create a 0 pair. So let's go ahead and multiply the top by -4. And maybe I should put that in red. We'll do the top by -4, and we'll do the bottom one by +3. Well, that's going to give me -4 times 3 is -12. donuts plus 20 or minus 20 coffees is going to equal negative 4 times 1320. Is that right? Okay, then we have 3 times the bottom one, so we're going to have 12 donuts plus 9 coffees is going to equal 750. All right, when we add these, we'll see these cancel out. We're going to have negative 11c. Did I make a mistake? What was that? Did I make a mistake? You sure? You have no clue? Oh, okay. Okay. Then we'll just leave it as you have no clue. All right. So we have 1320. We're subtracting 750 from that guy. So we're going to have 6. Yeah. Did you find one?
Yeah, 275 times 3
Is 825. Yeah. I don't trust my quick math in my head. That's why hopefully you guys have calculators. I can double check. All right, so this one's going to be 470. Yeah. Just checking. And I divide both sides by negative 11. What do I come up with? What does my coffee cost? Charlie? 25 cents. Is it 25 cents?
Oh, wait. Oh, sorry. Wait. He said 45, you heard 25.
Oh, okay. All right. That was the mix-up. Okay, 45 cents. Do I have the... Oh, I had it right here. Never mind. Then I can double check on my own. Yep, it's 45 cents. And I want you on your own, if you didn't already, your donuts should equal 35 cents. You're going to have to solve that on your own.